Page 654, we're going to do some reviewing on lessons 10.2, 10.3, and 10.4. So starting out here, lesson 10.2 is on simplifying radicals. The idea is here that we want to try to break these down as much as possible. So if we look on 23, what you can do here is if you want to go ahead and multiply 3 times negative 2, those are not under the radical, that would be negative 6. If you want to go ahead and multiply 14 times 21, you can. What I like to look for, that's going to be a really big number otherwise. I'm going to try to look for a perfect square. And so if you'll notice 14 and 21, neither one of those we can break apart to have a perfect square in them, but they both have a factor of 7. So I'm going to break the 14 up as 7 times 2. I'm going to break the 21 up as 7 times 3. And then I'm just going to rearrange. So if we did this, square root of 7 times square root of 7, that would be the square root of 49. And then square root of 2 times square root of 3 would be the square root of 6. So then this should be our answer for number 23. And again, there's other ways to do it. To me, that's the simplest way because you don't have to worry about having such a big number to work with. If we look at number 25, what's different there is that we have a fraction, and then also we have variables. So let's try to break this up. In the numerator, we have a 25. We also have an a squared. If you want to keep those under the same radical, you can. Those are both perfect squares, so that just leaves us with the square root of a. In the denominator, we have the square root of 4, and then that leaves us with the square root of a. So you could have actually, I'm just noticing this, sorry. You could have actually canceled out one of those a's before you got started, but this will work. So this would be 5a times the square root of a over 2 times the square root of a. And then since we didn't do it earlier, now we can cancel out square root of a. And you could rewrite this if you wanted to. Sometimes they write it like 5/2 a. Just make sure if you put the a next to it, that it's for sure next to it, that it doesn't look like it's in your denominator. Or you can just leave it in the numerator as 5a over 2. Then if we look at number 28, we have the 6 out in front. I was trying to work through this originally with breaking things up like I did on the last problem, but then it just got to be more work than what it was worth. So this is not going to be a huge number. I'm just going to go ahead and multiply these together this time, and then we'll try and simplify. So 5 times 15 would be 75 t to the 8th. And then we'll try to pull out a perfect square stuff. So 75 would be 25 times 3. And then t to the 8th, that's an even power, so we can just keep that there. Square root of 25 is 5. Square root of t to the 8th, what times itself would give us t to the 8th? That would be t to the 4th. So this would be 30 t to the 4th times the square root of 3. One other thing I want to mention in this section, the book didn't give us a problem like this here, but it's possible you could have something where you have a square root left in your denominator. So let's say we have square root of 10x cubed all over 13x. So this one, like the problem I had earlier, you could actually reduce the x's down first if you want to. So it's kind of like we canceled out one of our x's. So if one of the x's cancel out, we've got still x squared on top. And then you can simplify that. And then the problem is when we get to this point, we still have a square root in the denominator, and we can't have square roots in the denominator. It's not simplified. So you would want to multiply by the square root of 13 on both of those. And then that's going to be square root of 169, which ends up being just 13. Basically, square root and square cancel each other. So just make sure you remember that. You take care of not having any square roots in the denominator for your final answer. Section 10.3, we are looking at operations with radical expressions. So the first thing what we're doing here, we're trying to simplify the radical expressions. If you look at 31, both of those have square root of 6 next to them, so they're kind of like terms that we can combine together. So that would be 2 times the square root of 6. There's nothing more we can do to simplify that. On 32, if you want to, you can try to simplify underneath the radicals. So like square root of 8, you could split that up as 4 and 2, and you could simplify it. Actually, if you see what's coming, though, we have a number outside of the parentheses. We're going to distribute. And if you distribute, 2 times 8 is 16. Square root of 16 is going to come out even anyway. So rather than try to break that one apart, I would just keep it like it is, because then you're going to have square root of 16 minus the square root of 12. And then square root of 16 is 4. Square root of 12 you can break up. And so that would be 4 minus 2 square root of 3. And I had a sign mistake here, actually. Sorry about that. That should be plus instead of minus. Number 33, we've got basically a binomial times a binomial. So we're going to need to distribute or FOIL that out. So we're going to have 3 square root of 2 times 4 square root of 2 plus 3 square root of 2 times 2 square root of 5. And then watch your signs on this part. Minus 2 square root of 5 times 4 square root of 2 minus 2 square root of 5 times 2 square root of 5. So that's a little bit of work to get that all to fit in on the screen here. But at that point, we'll go ahead and multiply. So on this one, 3 times 4 is 12 square root of 4. And then this would be 6 square root of 10. And then minus 8 square root of 10 minus 4 square root of 25. And then if you'll notice, those middle terms are like terms that can be combined together. Also, square root of 4 and square root of 25 come out evenly. And then 24 minus 20 would be 4. Number 34, we've got a square root in the denominator. And for things to be simplified, we can't have square roots in the denominator. So to get rid of that, we need to multiply by what's called the conjugate. It's exactly the same except for the sign is different. So instead of minus 3, it's a plus 3 back there. So distribute, make sure you distribute to everything in the denominator. Square root of 4. If you want to shortcut and say that, I know it's going to be square root of 4, which is going to be 2, that's fine. Middle terms always are going to cancel out with conjugates. And then 3 times 3 is 9. So we work it out, we come out like this. Now the book has negative 3 square root of 2 minus 9 over 7. So to me, either way, this would probably be the more natural way to work it out, I think. For some reason, it seems like the book doesn't like to have negative denominators. Section 4, we were looking at solving radical equations. So we'll just look at a few of these here. So they want us to solve the equations, check the solution. If there's no solution, write no solution. Makes sense? So if you look at 38, the first thing we need to do on these problems is isolate the radical. We want to get the radical by itself. So this one they're adding 4, we subtract 4 on both sides. And then now we can square both sides, which is 9. And it's always a good idea to check your answer and make sure it works. Square root of 9 is 3. 4 plus 3 is 7, so that works. We go over to number 41. The radical is already isolated on this one, so we can go ahead and square both sides. And if you'll notice, we have a d squared now, and we didn't have a d squared to begin with. So this is most likely going to be where we'll have an extraneous solution. Since we have a d squared term and a d term and a constant, I'm going to try to get this set equal to 0. I'm going to pull it over to the right side, even though that's not normally what we would do, just because the d squared is positive over there. I like to have positive squared terms. And this will factor as d plus 1 times d minus 2. So either d plus 1 equals 0 or d minus 2 equals 0. D equals negative 1 or d equals 2. So if we substitute those back in the original problem, if we try negative 1 in place of d, that would say that the square root of 1 is equal to negative 1. That doesn't work. So negative 1 doesn't work. We can cross that out. So if we put in a 2, is the square root of 4 equal to 2? And the answer is yes. So d equals 2 would be our answer. D equals negative 1 was an extraneous solution. If we look at 42, this one has 2 radicals in it. And they're actually isolated as well as they can be. I mean, there's nothing really you can do when there's 2 radicals other than go ahead and square both sides. So 2 squared is 4. Let me do this differently just to make sure everybody's with me on this. On the right side, the square root and the square are just going to cancel each other. But on the left side, this would be 4 times square root of r squared, if you want. And then that's going to be 4r. And if you can get to that without going through those steps I just did, that's fine. Just want to make sure I didn't lose anybody. So then if you subtract 3r on both sides, 1r equals 1, and that's just the same as r equals 1. And then if you test that, is 2 equal to the square root of 4? It is, so r equals 1 is the solution for that problem. And then if we look at number 44, the radical is already isolated here, so we can go ahead and square both sides. That would be 4x squared. And again, we've introduced a squared term that we didn't have before. We have a squared term, an x term, and a constant. So once again, I'm going to set this equal to 0. If you want to do that in a couple of steps, you can. This one does have a greatest common factor of 2. So we can factor that out, give us a little bit of smaller numbers to work with. Signs are going to need to be different, and we need more positives. So if we try it this way, that would be plus 2x minus 1x. That works. And so at this point, we can set our factors equal to 0. So either 2 equals 0, it doesn't. 2x minus 1 equals 0, or x plus 1 equals 0. So that one would say x equals a half, and this one would say x equals -1. And then if you substitute those back into the original equation, what's going to happen is the 1/2 is going to work and the -1 is not. So in order to not make this video too long, I'm not going to go through that whole process, but x equals 1/2 would be our answer for this problem. We'll look at page 657. Basically, numbers 8 through 21 are the ones that go with what we're doing here. So I'll just go ahead and try to quickly work through these in case anybody's doing these and has any questions. For number 8, square root of 12, we can break that up. And so then when we have square root of 3 plus 2 square roots of 3, so that's like 1 square root of 3 and 2 square roots of 3 gives us 3 square roots of 3. Number 9, square root of 300, we can break that up. Perfect square, and that would be square root of 100. So that would be 10 square roots of 3. Number 10, you can put a 1 in front of the second one here, and that would be 3 square root of 10. Number 11, we can pull out some perfect squares. So this would be -3 square root of 2 over 2 square root of 3. You can't have a square root in the denominator, so go ahead and multiply by square root of 3, numerator and denominator. And that's going to be 2 square roots of 9 in the denominator. Square root of 9 is 3, so then 2 times 3 is 6. And then you can actually at that point reduce with the 3 and the 6. So if you reduce both of those by 3, it'd be -1 square root of 6 over 2, or just negative square root of 6 over 2. Sometimes when the book writes their answers, they put that negative sign right next to the fraction bar. I don't like that because it's real easy for that to blend in with the fraction bar and not be able to see it. So make sure you put the negative up with the numerator. Number 12, we've got a denominator that's a binomial, and it's got a radical in it. The only way we can get rid of that is to do the conjugate. So if you distribute that, denominator, that'd be square root of 9. Middle terms cancel, and minus 16. We really don't need the 1 in front of the square root of 3, so I'm just going to drop that off. And I think I mentioned before, the book doesn't really care for negative numbers in the denominator. So if you just multiply a numerator and denominator by -1, you would get this answer. I'm okay with this answer that we had before, though. These are the same in my view. Number 13, same idea. We would need to multiply by the conjugate here. So 4 plus the square root of 6. Middle terms cancel. And then if you notice on this one, when we get to this point, in the numerator, we can factor out a 2, which I wouldn't do except for the fact that the 10 in the denominator also has a factor of 2. Since it's being multiplied, we're allowed to cancel those out then. So this would be our final answer. Number 14, same idea again. Multiply by the conjugate. They're giving us plenty of practice on these here. Middle terms cancel. And that should be our answer. Again, the book's got it switched around with no negative in the denominator, but I think we're good. Number 15. We can go ahead and I'm just going to multiply those together. I know I've talked sometimes about trying to look for perfect squares or numbers that are the same, but let's just multiply them together first. So with 50, we can do 25 and 2. X to the 6th, that's an even power, so that's good. And then if you multiply those together, that's -15 x cubed times the square root of 2. The next part, they're wanting us to solve these equations, check our solutions. On 16, we need to first isolate the radical, so subtract 4 on both sides, and then square both sides. Divide by 2, and then you can just leave it like this. If you put 4.5 or something would be okay, I guess, but you can just leave it as 9/2. On 17, we need to add 8 first to isolate our radical. And then that's 1,296. 18, that's a different look. We've got a 3 in the denominator, so multiply by 3 on both sides. And then square both sides. and divide by 3. And you can just leave it as 7/3. Number 19, there's radicals on both sides. So they're both isolated. We'll square both sides. And then we have x's on both sides, only one constant. So you subtract 2x on both sides, you get x equals 4. I haven't been checking my solutions here, but to this point, all of them are good. I'm just going to save the length of this video by not going through every single one of those. And like I said, pretty much it should work out unless you create a squared term that wasn't there before, then you probably aren't going to have any extraneous solutions. This one, we are creating a squared term. So set that equal to 0, and then you can factor that. So that would say either x equals -2 or x equals 1. Like I said, one of those is not going to work. Let's see which one it is. So if you do -2 for x, that would say square root of 4 equals -2. That doesn't work. So the other one hopefully works. If you put a 1 in, square root of 1 equals 1, that works. So x equals 1 would be our answer for that one. And then on 21, go ahead and square both sides. If you're looking at that, if you were thinking, well, it's just not going to work because we have a square root of something that equals a negative. It's equal to -a, but we don't know if a is positive or negative. So if it was just like equal to -5, then right away we say no solution. But as it is, a could be negative, and then the opposite of a negative would be a positive. So we're actually still in the game here. So either a equals -6 or a equals 1, and again, one of those is not going to work. Well, if you even just think about it, if a was 1, you'd have the square root equaling a -1, so that can't work. If you try the other one, if you try -6, you got to be careful with all these signs here. Oh, as I say that and put my sign in the wrong spot. So this would say square root of 36 equals 6, so that works. So a equals -6 would be our answer to that problem. So this gives you an idea what we're looking at in lessons 10.2, 10.3, and 10.4.